Today's Expert to Expert webinar series is sponsored by Schneider Electric and its various brands. Hello, I'm Wendell Leisinger, your moderator. I am the Consulting Engineer Segment Manager for Schneider Electric. Let's go through a few housekeeping rules. So for the Proficient for Professional Engineers webinar, please join our Consulting Engineer portal, where you can access the continuing education modules and have the ability to manage your courses and get the continuing education certificates. Also, we have direct access to things like Layout Fast, our building information models, design applications, calculators, and other product specifications. Also, the latest in products and solutions to give you and your designs the needed edge. Please note there is a survey at the end of this webinar that we'd appreciate your feedback on. The certificate of attendance is as follows. If you've already registered for the portal prior to this webinar, then simply follow the instructions on printing your certificate provided at the end of the webinar. However, if you have not registered previously and plan on doing so during or after this particular webinar, your certificate will be available 48 hours afterwards by registering on the portal. If you have any problems, questions in regards to receiving your continuing education credit, please use the link below for our partner portal support team. Also, your dashboard has several buttons at the bottom of it. For technical support, the first button on the bottom left allows you access to our technical team if they're having technical problems with this webinar. The second button gives you access to the link for our Consulting Engineer portal and also the capability of downloading this particular presentation. The third button, which is your viewing button, which you're using right now, allows you to view the webinar. There is an enlarge feature in the top right-hand corner to allow you to enlarge the screen. Also, the red button is used to type in your questions. We will not be taking in questions verbally. We'll be taking them in as you type them. I will be managing those questions as we go through the webinar. We also have social media links. And also, to complete the survey, the second to last button allows you to complete the survey anytime throughout this particular webinar or at the end. We will let the webinar run for 5 minutes afterwards, so you can do that. So let's get started. The learning objectives for today's webinar: understanding and integrating smart systems into your plans. Understanding smart electrical distribution systems and how they're connected. We also are going to talk about the communications protocols, allow you to also understand how smart systems help you and your customers, how and where to integrate smart systems into your plans, and we will be reviewing state-of-the-art systems solutions for you to use. But before we get started, we have a polling question. The polling question allows you to answer this question: what percentage of your customers are interested in connected electrical distribution? The answers are 0, 10%, 25, 50, 75, and 100%. I'll allow you a few seconds to answer those questions, and then we'll take a look at the results. Thank you for your response. Looking at the answers. So it's pretty even across the board. What would I like to do now is I'd like to introduce you to our presenter, Duke Dunsford. Duke is a certified energy manager and also the offer launch leader for partner projects within Schneider Electric. Duke also has a passion for providing information for users to be able to make the best of their electrical power solutions. With that, I'd like to turn it over to Duke.
Hello, everyone. Thank you, Wendell. I appreciate the opportunity today to get together and discuss a little bit about connected electrical distribution. As Wendell mentioned, I work in product marketing at Schneider Electric. I've been working with the connected portion of power distribution since the latter part of 2014. So hopefully I can share some information with you today to help bring you up to speed on this technology and how you can better use it and how you can benefit your customers with this newer technology. So we'll start out with a discussion of what is a smart system. So many manufacturers have different ways of describing this. For today's presentation, we're going to describe it as a smart system. And what we're talking about is a connected data network inside or connecting your electrical distribution. And we're going to talk specifically about the low voltage electrical distribution. Of course, you can connect medium voltage as well, but for the sake of this discussion, we're going to talk about low voltage because it's really where that energy is dispersed through a building or a facility and where we really see the most exposure of the ability to do something with that data and manage the data, manage energy, manage our assets inside the building. So today we're going to talk about LV electrical distribution. And we're going to talk about what's driving this. So fundamentally, what's driving the ability to connect things together is described by many as the Internet of Things, also known as IoT. So you may have heard this term, IoT, and it really is talking about all the things that are connected in the world. So all the Ethernet connected devices in our lives. So on the consumer side of this, we're all very familiar with our smartphones. So we're connecting a smartphone to the internet, we're connecting it to email, we're connecting it to all manners of wearable devices, so smartwatches and things that can keep track of your pulse at night when you sleep. We connect to our TVs with smart televisions, smart appliances. We have home lighting and HVAC controls. Everybody's familiar with the Nest thermostats. So we have all kinds of things today that are connected through the internet through this IoT concept. There's, they say that at the moment there's approximately 6 billion IoT devices as of 2016. That is being pushed out, forecast for 2020 to be as many as 20 billion IoT devices. So this is something that's very prevalent in our society, and it's something that we are all used to seeing, and it's becoming more and more part of our daily lives. There's another portion of IoT, which is referred to as the industrial IoT. So this is kind of a subset of the entire topic, but this is referring to IoT as it's defined inside of an industrial platform or industrial sort of area. And so what this is speaking of is operational efficiency inside of industry. So it's tying together things like supply chains, machines, services, the workers themselves, and it's taking all of those pieces and connecting ecosystems around software platforms that really help us be more effective in our industrial world. So we're collaborating around humans and machines and the data that's available about all of those pieces. And it's really bringing an unprecedented level of productivity inside the industrial world. It's also bringing out some outcome-based services. So by that, I mean things like guaranteed levels of machine uptime or the amounts of energy savings that are used in a commercial building. So that is leading us to this kind of smart systems discussion around being able to guarantee uptime, to be able to understand energy use, and to be able to save energy and ultimately save money for our customers. Another way of looking at this is around what I'll call a smart automobile. So many cars that you can buy today are ultimately connected vehicles. So your car can email you when it needs service, or it can tell you if a tire is going down. So inside that car, there are all kinds of sensors. So it could be anything from, again, your tire pressure. It could be sensors about your oil level, viscosity of your oil, all sorts of things that are rolled up together inside the car's computer, and that connects to the displays in your car, which allow you to do something with the data. So either you can see it from a standpoint of the user of the car, or there can be some sort of analytics that are available, or even, as I mentioned earlier, the car can send a message to tell you, I need some service. But there's that connected interior of the car really helps you from knowing how to save money by using less fuel or by doing maintenance at the right time so that your car lasts longer. And there's even a safety factor of driving down the road and knowing that your tire is going down before you have a problem. Now, if you take that concept of measuring, connecting, and then saving with that information, and you take away the connected part of that, you have a situation now where you have a car, you have the same features going on inside the car, but you don't know about them. So you have no connectivity to know, say, your oil level in the car automatically. You are dependent on going and looking at the gauges on the dash, and really you have a very limited amount of information that's available to you, and the only analytics are really based on what you can see there on that dashboard. So that carries us into a discussion of a smart connected electrical distribution system. In today's circuit breakers, we have migrated from previously having something as simple as just an on and off switch, a manual switch. That technology has moved into a higher technologically advanced breaker, which might be a thermal magnetic breaker, which has some technology in it, but it still doesn't communicate. The only way you know what that breaker is doing is by looking at the lever, and you can see whether it's on or off or whether it's tripped. So very simple device, not communicating, not connected. Then we migrate to what we have today in our modern communicating circuit breakers, where you have electronic trip unit, you have embedded metering inside the breaker, you have sensors on the breaker that can tell whether it's on or off. You're able to communicate all of that data out of that breaker out to some web platform or some computer that's able to look at the data, understand the data, and do something with the data. So things like energy profiles. How long has the breaker been used at a certain loading level? And it indicates how much life is left in that breaker, or even if there's an overload situation, so that you can see what's going on inside the breaker, do something with the data before you have a problem. So how do we define what we call a smart distribution system? Here's one way that that's defined. Many people define it in different ways. So here's one example. It kind of goes back to that car situation. You have a measure component, you have a connect component, and you have a visualize component. So on the measure piece of that, you're able to use the embedded breaker metering or the embedded status of the breaker, communications of that information. Or you're able to use information from, say, external metering. Those are all measurement pieces in the scenario. You take that data and you connect the data. So in that case, now you're moving that data out for web access locally, you're moving it to access from an enterprise software platform, or you're moving it to the enablement of a cloud services platform. But you're taking that data from the sensors and connecting the data. And then lastly, you're visualizing the data. So this is taking the data and moving it to a display of some sort so that you can do something with the data. You can give it further attention where needed. You can analytics work. You can use it for services, enable services to know that there's an issue that needs to be taken care of. But ultimately, that visualization is helping you do a couple important things. One is save energy. The other is maximize uptime. So those are the two key pieces inside electrical distribution which are important, is that energy piece, uptime piece. So what's at the core of the smart system? What parts make this up? Essentially, when you're talking about the breaker side, you're talking about low voltage power circuit breakers, or our larger breakers. We have also molded case circuit breakers, which are the smaller circuit breakers. On the larger side, you would have a fixed breaker, like in switchgear, or a draw-out breaker. And then in the molded case breakers, of course, those are the smaller breakers. But each of those have communications capabilities. Or you have power meters, which today are very commonly Ethernet-enabled power meters. So they connect right into the Ethernet network, and you can get the data out of those meters. We have interfaces, which allow us to see that data or move the data around. So this would be taking the data, moving it out to Ethernet, Also allows us to do things like and again, breaker status or do predictive information, or even control a breaker. So from a remote location, allow you to turn a breaker on and off. We commonly use Ethernet, so I'll talk about Ethernet a lot today. Used as a common platform. We all know Ethernet. We have Ethernet infrastructure that exists almost everywhere now. It's very common devices everyone understands. We also have embedded web pages. So this is becoming more and more common where you have an embedded web page inside of a device that can be accessed from a web browser. So very simple access. You log into it just like you do any other web page. You can see that type of data from a tablet or an HMI. It really provides you a convenient or local or remote access to that information. And then lastly, the equipment is often connected to an enterprise software. So when I talk about enterprise software, I mean software that's used in a large industrial situation, a large factory. We have a SCADA system or an EMS, energy management system, or a building management system that's looking at a lot of different features of the building, one of those being the electrical system in the building and able to monitor that from a central location inside of a building. So here are a couple definitions or terms worth knowing. I won't go through all these in great detail, but I did talk about embedded metering. And embedded metering typically uses what's called an electronic trip unit, which is a part of the breaker. And that's a device which is used to measure the current flowing through a breaker for trip events. So because that information exists in the electronic trip unit, it's very reasonable to take that data, pull it out of the trip unit, and view it somewhere else, so on a PC or as part of an energy management profile. So that information being available from the electronic trip unit, kind of what this is all based on, is able to connect and see that data. I want to talk about Modbus a little bit. There's several common protocols used for communication. One I'm going to key on today is Modbus. Modbus was first introduced back in 1979 by a company called Modicon. Modicon was purchased by Schneider Electric. Then later on, the Modbus profile or the Modbus protocol was turned over to another group. So Schneider no longer controls it, but it was originated inside of Schneider back in the 70s. But it is considered an open protocol, meaning that there's nothing proprietary about Modbus. Every manufacturer knows what it is, how it works. There's nothing hidden. And the registers that are available to Modbus are something that is really cross-platforms and allows many different devices to be able to be connected. There are two forms of Modbus that we'll talk about. One is Modbus RTU, which is Modbus Remote Terminal Unit. That's serial communication, Modbus over serial communication. And the other is Modbus TCP/IP, TCP/IP standing for Transfer Control Protocol over IP. So the first one of these, Modbus RTU, which is also sometimes known as Modbus RS-485, that's serial communication, and it's really limited by the parameters of a serial network. So this is the original protocol that was built back in the 70s. And with a serial protocol, you're dependent on each message being sent and then received back. So you send out a request and you receive back the answer, and then if that happens, you send out the next request, that next answer comes back. So you have kind of this chain of messages that are waiting in line. And as you get more and more Modbus serial devices on a network, that message time gets longer and longer and longer. So there is some limitation on Modbus serial of how many devices can go on a network and the effectiveness of that network as it gets. When we talk about Modbus TCP/IP, that's Modbus on Ethernet, a lot of those problems go away because with Ethernet, many messages can run simultaneously. You don't run into that problem of messages getting backed up. So you have a more effective and a more efficient way of transmitting multiple messages at the same time with Ethernet. So Ethernet was obviously introduced at a later time, and Modbus TCP/IP is utilizing that Ethernet capability. A couple other terms worth knowing. We'll talk about IPv4 and IPv6 in particular. So IPv4, Internet Protocol version 4, was established back in the 80s, and it uses the common 12-digit IP address that everyone wants. The issue there is that there's only approximately 4.3 billion addresses available on that that standard. So we've run into an issue with IP exhaustion. So essentially, there are no more IP addresses available. As I mentioned earlier, there are approximately 6 billion IoT devices today, with as many as 20 billion being out there into 2020. So obviously, having only 4.3 billion addresses. So that's where IPv6 was introduced a few years ago, which replaces IPv4, and it gives us a infinitely larger number of IP addresses, which we will not run out of anytime soon. So the reason I bring that up is that many devices now, or most devices, have this IPv6 technology. If you run into an IPv4 device, you just have to remember that you do have an IP exhaustion issue up, and it's very helpful if devices have migrated over to IPv6. Another term I'm going to talk about briefly is DPWS. Maybe you're less familiar with that. This stands for Device Profile for Web Services. And this is a feature that became available back when Windows Vista came out, and Vista Forward DPWS has been available. What it does is it allows devices to be found on a profile where you don't have to know the IP address. So if you've ever seen an IPv6 address, it's a big long string of numbers. It'd be difficult to type that in manually. With DPWS, the device actually has a dynamic discovery inside the computer. You pull up your network page, network device page, the network devices all appear there. You double click on the device and you're able to get to it. So very, very convenient way of accessing devices using web services through this DPWS feature, now available in. Lastly, I'll talk about EPMS, which is Energy and Power Management System. This is an industry term that's becoming more and more popular, and it refers to bringing together SCADA systems and energy management systems like a singular platform. So when we talk about EPMS, we're talking about the whole umbrella of energy management software and supervisory control software kind of rolled into one. Okay, so looking at kind of what we've been talking about, when we talk about a smart system, fundamentally, the information that's available from the equipment goes one of two places. Number one, it goes out as data, as raw data being sent out to this enterprise level software, this EPMS level software that I discussed just a second ago. We have data that's being pushed to a SCADA system or a BMS system, cloud, or any external software that needs to see the raw data. So talk about Modbus. This is Modbus registers being sent as raw data out to these platforms. The other place that the data is used or available is in localized web servers. So this would be localized data that would be in an interface or a meter or some device that has an available web server on board the device. The computer can literally be plugged directly into that device. Web browser can be pulled up, logged into the device, and now you have pre-configured web pages available from that device. So effectively, those two places are the areas that this data is going to. Obviously, if you have a local display, a HMI or a monitor of some sort, it's going to look at either the raw data or the embedded web page, one or the other. But effectively, this is where the information goes and how it's extracted from the devices. Now, some of the value propositions that you get from having this data are around things like connectivity. So when you have Ethernet connectivity, that gives us fast and dependable data that really helps maximize uptime. Things like cloud capabilities allow us to have remote access, save labor by not having to send somebody out to a site. You can look at it remotely. It's going to help you reduce energy use because of that. Things like embedded metering with communication gives you efficient energy and asset management. Really helps operating expense side. Back to what we were just discussing about not having to send somebody out to a site when you can log in remotely and see information. Interoperability is a feature that helps on the commissioning side. So it helps us with the integration piece of this, so that things can be integrated easily by using protocols. There's some regulatory and safety issues around the C240.87 code, and that's an entirely different discussion we're having today. But on arc flash mitigation, where you need to be able to turn on and off a safe mode or a reduced energy mode on equipment. By having communications capabilities, that can be done remotely. You don't necessarily have to go up and touch the equipment to turn that on. We also have power control and reliability functions, where, again, we have remote control of a breaker that's possible. So if you have a breaker trip at a remote site, it's possible to get online and turn the breaker back on remotely. So all of these values really can help from the perspective of taking our old technology and moving it to the future of having this connected, smart, intelligent distribution system that gives the user that much more capability. So pulling all this together, what does it look like? We have on the left different types of equipment, so everything from panel board up to switchgear. That information that's from those devices inside that equipment now enabling the connectivity to data systems, cloud applications, local web access. And really what that does is facilitating some of these value features on the right. Things, again, like remote access, remote service access, energy awareness, things like event alarms, alerts, predictive maintenance piece. We can understand what's going on in our equipment before we have a problem, ultimately maximizing uptime. I mentioned earlier, but the two big key factors are energy awareness and saving energy, as well as maximizing our uptime, maintaining our equipment at its best possible to provide a customer a maximum performance from their equipment. Now, what's driving the demand for something like a smart system? Several things. Energy awareness is a big, so everybody is aware today of our green initiatives that are very common. So the ability to understand where energy is, how it's used, where we may be wasting energy, how we can save energy, that energy ultimately save money. So that's part of what's driving this. The interconnectivity piece, by using open protocols or standard protocols to be able to interconnect different devices inside of a building. Being able to get all the way down to the breaker level of data, and not just using a meter, but going all the way down to the granular level of the circuit breaker itself and understanding data from that breaker. Predictive and preventative maintenance. So maintaining equipment not only on a schedule-based system, but also on an event-based system. So if you have some unexpected event that happens with that circuit breaker, you know that there's a problem, you can go and take care of that problem before you have an issue. Managed services. So the remote connectivity to the equipment allows service organizations to see that there may be an issue. They can have a truck rolling and on the way to a customer site before the customer even knows there's a problem. So that's a big enabler for this. Electrical asset management. Some people ask, what's an electrical asset? Well, that really can be everything from the equipment that distributes the energy all the way to the quality and the reliability of the electricity itself. So understanding that electrical asset piece is another big part of this. And then ultimately, future-proofing. So having the customers ready for the future, able to use the new technology and data that's available to them today, and for you as specifiers, consultants, being able to put that technology in the hands of your customers and have them ready for the future, leading edge of technical advancement. So that's really the keys that are around what's driving the demand for this smart type technology. Now, where do we use this technology? I mentioned it a few times, but one of the places is in critical applications, such as data centers, healthcare, critical industry, places where uptime is a primary requirement. So understanding, again, that status of your equipment and knowing that the equipment is healthy and that we're maximizing that uptime in those areas where this is an absolutely critical requirement. Another place that's used is in non-critical buildings, things like education, commercial, retail, where uptime is not the big thing, it's the awareness of energy use, which is the primary driver. So places where you have an energy manager who's interested in granular information and understanding where the energy is used and how it can be saved, those places the technology is applicable as well. Third area is cloud-based applications. So for services or a remote multi-site access to data, where you can have that remote access and, again, save labor and time of not having to go to the site to do any kind of analysis. You can do it remotely. And then lastly, in small and medium buildings, where a standalone system is appropriate. So we talked a minute ago about embedded web pages. So when you have an embedded web page, you don't need any other software. Your computer literally logs into the device, you pull it up on your web browser, and that's it. So for things like small commercial or small retail, remote small industrial, multifamily setups where there's no BMS or EMS system that exists or even required, but yet a local monitoring system does bring value. So really this is scalable, everything from that big, large, critical application all the way down to the small application where it's a standalone system. The technology available from the equipment applies across all of those, that entire range. Okay, so Wendell, you still there? I think you had a question for us.
Yes, Duke, thank you very much. You may want to adjust your volume on your phone, Duke. We're hearing a few things that you're a little bit hard to hear. In any event, we have a lot of questions coming in. A lot of them you are addressing. Question number 2 in a moment, but the questions that are coming in are a bit more about the technology that is available in our metering and in our circuit breakers. And also there's some safety concerns that, for example, when Duke said there was the capability of remotely operating a breaker, what are your safety protocols in regards to that? Please keep those things in mind. We have a lot of capabilities in this technology, and whether you're not on how you use that technology is dependent on how you put it together, and obviously safe design is very important. With that, number 2 question was, do I have extra software to see embedded, do I need to have extra software to see embedded web pages inside the device?
So no, the answer to that, Wendell, is no, you don't. Whenever you have an embedded web page, fundamentally that means that the web page is available to a browser. So when you have an embedded type application, often you have pre-configured web pages. So in that case, you log into it with your browser just like you would log into any other website, and you don't need any other software available for that. And then I mentioned earlier about the introduction of DPWS, which was Device Profile for Web Services. And with that, the requirement for knowing the specific address of a device that's DPWS capable, it becomes a non-issue. So again, you pull that device up on your network devices page on your computer, you double-click on the device, and oftentimes a page comes up where you put in your login and your access to that web page, your security access, and then you're in. So now the pages are there, they're pre-configured. It makes life very easy. So you don't need any other software. It makes it very, very easy to get to this data.
Thank you, Duke. With that, I'll let you continue.
Okay. So moving along, what we got up now is a practical example of smart systems. So in this case, we're talking about some low voltage equipment that's tied to an EPMS system. So again, the EPMS was Energy and Power Management System. And in this particular application, we're going to look at something called a breaker performance module. And what this does is it allows you to use data that's available from a breaker and see the actual status of the breaker on a this is a module inside of an EPMS software. And it's looking at critical circuit breaker information and helping you proactively schedule maintenance for that breaker by understanding things like the breaker aging. So where is the breaker in its lifespan? And a lot of that information is calculated or determined by the status of the breaker, the environmental factors around the breaker, things like the loading of the breaker, every time it was opened and closed, how much did that contact wear down? In the old days, you had to open up a breaker and physically measure the contact to see how much wear there was. Today, you have a way of measuring that from software. So going in and seeing how many times did that breaker open and close, how much wear was there based on all the external factors on that breaker. What was the loading when that thing opened and closed, and how much wear did that create? So what that does for us is it allows us to pinpoint equipment that may be at risk. So in this case, a little red notification comes up, says you have an issue with that breaker. You dig into that breaker further, and you see that the breaker aging is becoming a critical factor. Now you know we need to get services out, take care of this breaker, make sure that it's been updated or serviced properly, and then it's ready to go. Without this type of information, it'd be very difficult to know that the breaker was nearing the end of its lifespan. So this really makes things easy from a perspective of understanding how much of your breaker's lifespan has expired. So this is just one example of how that extracted data from a breaker can be very, very helpful to a customer. Okay, so we have another poll question. Wendell?
Yes, thank you, Duke, for giving us that insight on our breaker technology. With that, we have a couple polling questions. The first polling question is, how important is open protocol communications to your customers? Again, how important is open protocol communications to your customers? Not important, somewhat important, very important, or is it critical? Give you a moment to submit your answer. Thank you. So many of you are reporting it's very important. Yes, we understand. With that, I have one more polling question. When specified, do you look for a single manufacturer to supply a complete integrated solution? Again, when specified, do you look for a single manufacturer to supply a complete integrated solution? Not important, somewhat important, very important, or critical? Give you a moment to log your answer. Thank you for your response. Again, very important is the response, Duke. With that, I'll turn it back over to you.
All right, thanks, Wendell, and thanks everybody for your replies on those survey questions. It's very interesting to see kind of how a large group of people reacts to that type of technology and how we use it. So I want to move on now to how does a smart system help you as a specifier. So there's a few points here to be aware of when you're working with this type of technology. One of them is blended technology, which can help provide a single solution. This kind of reflects back to the poll questions we were just looking at. Being able to take a single vendor who can produce the hardware, the software, the commissioning, and the services of the equipment, and all of those come from the same vendor. So with this, you kind of have that comfort factor that everything works together, everything is designed to operate together. The commissioning folks understand the entire system and put the whole thing together and give you a comfort factor that you specified something that didn't cause any problems on the commissioning side. So it really works towards reducing those commissioning errors if you're going to have dissimilar systems that are all tied together, which of course happen all the time. Not necessarily problems, but dissimilar systems are put together all the time. But by having a vendor that does produce the entire range of software, hardware, services, the whole thing, you really have a comfort factor there. Another piece is Ethernet. So by using Ethernet, specifically in this case Modbus TCP/IP, it really helps avoid some of those common connectivity issues you may have with dissimilar systems. So, or by using serial systems. So we don't want to find out that there's a serial network issue that happened, could have used Modbus TCP or some other Ethernet protocol. Critical and non-critical applications both can be addressed with a scalable system. So we talked about this a minute ago, that you can have a standalone system with only embedded web pages, or you can also have this enterprise level software that for a larger application. But the equipment itself, at the core of the equipment, it's really doing the same thing. So it becomes a very scalable application. And then another piece here is project cycle time can be improved when you have a factory assembled pre-configured system. So in a case where you have factory wiring, factory communications, all the pieces are set up and pre-configured, shows up on site. There's sometimes plug-and-play devices, which you literally just plug them into each other and they run. It really helps to have those pieces that operate together. It helps to have things, other factors like reduced wiring, hardware requirements. The embedded metering piece is another part of that. So from a project cycle time, a lot of those pieces can be improved by having pre-configured, ready-to-go communication systems. And lastly, I'll mention TVDA. So TVDA stands for Tested, Validated, Documented Architecture, meaning that everything works together as a tested system. So now you know that all the equipment is designed to work together, it's tested together, and it's set up and engineered in a model that is a known functioning model where you don't have any issues that you're going to run into at the job site when we go to the commissioning stage. Now here's a couple examples of specifications that are in existence today. So one of these is for low voltage switchgear, which is hardware, with smart systems communications capabilities. And I just cut out the communications portion of this, but it lets you kind of see this integrated specification that brings together both the hardware or the equipment as well as that communications piece. So if you look in here, there's things like Modbus TCP is called out, things like Ethernet, of course, historical trending, alarming, maintenance indicators, email alerts, all those sorts of things that come together in a communicating system. And this specification allows you to really see that that these are out there. So you should be looking for manufacturers that can provide this kind of a spec and pull this information in a convenient way. Another spec that I'll show you real quickly is an EPMS spec. And inside the software, this software specification is the language about low voltage draw-out switchgear. So again, here's an integrated solution or an integrated specification that pulls together equipment and software into the same spec. So again, look for manufacturers that have this capability and have these specs that can allow you to pull these pieces together in a very easy way. All right, I want to show you kind of an example of a connected system. So we go way back to the car discussion we had early on where we talked about the measure, the connect, and the visualize or act components. So in this case, the bottom on the left, we have the measure components. So we have, in this case, power circuit breakers, below the case circuit breakers, power meters, all devices that have measurement or metering on board. In the middle, we have the connect piece. So now we have devices which take the information from the breakers and convert those that information into Ethernet. So the green lines at the top are all indicating Ethernet. And then on the top level, we have this visualize. So the visualization of the information is available from a HMI, it's available from local web pages on a web browser, or it can be pushed again out to that EPMS level software. So this would be a very typical example of a system which had all of those components in it and really provided you a complete solution to provide the information directly out of the breakers to the customers. There's other pieces in here like the data logger there at the right, which can store data and use that stored data to push it out to the cloud. So looking at this model, this would be a very typical example of a smart system. All right, here's another application for a healthcare situation. This particular application is an intelligent surgical unit where we have several monitor components. We have the power panel, which is monitored. We have a monitored UPS. We also have a monitored isolated power panel. So in this case, each of those devices is tied into both the energy management system in the building as well as the power management component in the building. So if you have any issues with any of this equipment, the facility folks know this immediately and can go address those issues. And in fact, you can't see it on this drawing, but upstream from this power panel would be the big distribution breaker, and it's monitored as well. So now there's 4 steps in the process. Every one of those are monitored. If there are any issues with any of them, that awareness is there. So this would be the place where you would want that maximized uptime, because obviously in a healthcare situation, it's of critical importance. Okay, so in summary, what we've talked about is the visibility of low voltage power distribution. So that enables the user awareness and status. So we understand energy use, we understand critical applications, we understand breaker status. We are able to react to issues before they occur, so maximizing uptime. We can anticipate operating gaps within our facility by seeing and understanding all of the data. The other piece we talked about was connecting with Ethernet. So we're moving from a serial world that we've been in the past, moving towards Ethernet, trying to standardize on a stronger Ethernet backbone using common Ethernet architecture, common Ethernet equipment that is everyone knows how to use. So we're future-proofing our equipment and our infrastructure. We want to help you keep your clients on that leading edge of technology. We're standardized again on Ethernet, so it's the simple, fast, reliable format. We use open protocols with things like Modbus TCP/IP. There's TVDAs, so tested and validated architectures. So we know from the design side that there's ease of design by using it in an architecture which has been tested and validated. Then we're evolving to a cloud-based and a high level of operational services with information everywhere. So back to that IoT discussion, we expect to have information on our smartphone that we can pull up and see on an app. Those things exist today. So again, future-proofing our customers and allowing them to have the best possible technology, really what we want to key on and where we want to help you guys focus on being able to provide that service to your customers. All right, so that's it for me. Wendell, do we have any additional questions?
Yes, Duke, very good. Well, you are answering, or you answered one of the questions that came in, is how can consultants sell the upfront cost, including in smart distribution systems versus standard systems? That last slide was very powerful in giving the value propositions around that. There are a lot of questions coming in around the technology of our devices, whether it's metering or circuit breakers, very deep conversations or questions in regards to contact wear and other types of things that we will not be able to answer on this particular call. However, we will answer all of the questions. We will get back to you within the next 24, 48 hours to be able to answer your questions and give you the insights in our technologies. There is a question number 5, Duke. If you're already using a power meter, why would you also need to use embedded breaker metering?
Oh yeah, that's a great question, and that question comes up a lot. So effectively, you have a meter which is often mounted upstream from the breakers, which that circuit's feeding. And so the meter is often used as a critical power analysis tool. So the breaker information, the metering information that comes from the breakers is a lot of times based around energy awareness and the status of the breaker. You still use the power meter as that critical power monitor because of the depth of knowledge that you can get out of an advanced meter. But by having embedded metering at the breaker level, that data really becomes granular. So if you have a single meter on an entire piece of switchgear, for instance, you don't see where each individual circuit loading is or anything about that particular circuit. So essentially, when you have things like a power management software, having the capability of things like energy benchmarking to identify specific opportunities at the breaker level is important, where if you had a single meter, you may not be able to do that. So effectively, embedding all this metering in the breakers gives us expanded granularity of the data.
Thank you, Duke. Great presentation. This presentation is recorded and can be viewed afterwards. Want to remind you, please join our portal and to get your continuing education credit certificates, and also the other information that's available on our portal through layout fast tools, building information models, design applications, et cetera, et cetera. This webinar, like I said, is recorded. Take your survey or give us your feedback in your survey. That's very important. And now we're going to show you a brief video of the highlights from our webinar. So thank you very much for attending today's Expert to Expert webinar series, Understanding and Integrating Smart Systems into Your Plans.
Today's busy consulting engineer needs more than just a helpful website. You need a trusted advisor and guide for insight and support. With our new Consulting Engineer web portal, Schneider Electric is just that, an expert source for product information, a seasoned second opinion, a layout specialist, a news and information resource, your own customized support system that makes you, your projects, and your business better. Product catalogs, technical support, codes and standards detail, specs, layout and coordination tools, expert insights, and industry updates are all as close as a simple click. Got a product question? Access our enhanced digital version of the yellow binders you may have used in the past. Digest Plus gives you instant online access to Schneider Electric's entire product line with technical, application, and layout information on our complete product catalog. Trying to choose the right circuit breaker? The Selective Coordination tool lets you quickly test various system and breaker combinations, allowing you to conduct preliminary analysis on the fly. With your product selected, you can configure and insert them into your design in seconds with our Layout Fast app. The Schneider Electric Consulting Engineer portal allows you to make quicker, better informed decisions that you can apply immediately to your project plan. Speaking of staying better informed, your portal is also an ever-changing information hub with continuous updates on products, industry news, and educational opportunities. A quick scroll through the homepage gives you instant access to our ARC Flash Resource Center with industry white papers, webinars, and analysis on today's most complex code issues. Technical specs, codes and standards, and a BIM library with small, rich product model files you can download. A powerful product FAQ tool for quick answers to your most common questions. A comprehensive white paper library with the latest engineering insights and best design practices. Up-to-the-minute industry news with continuous updates on events, tools, products, practices, anything relevant to your business. And to stay educated on all of it, webinars, online training, and meeting events to keep you current while allowing you to earn PDH, CEU, and other continuing education credits. When it comes to easy navigation and instant access to everything that improves both you and your projects, the Schneider Electric Consulting Engineer portal is your essential one-stop support center.